All right, so meso compounds are molecules with asymmetric centers. All right, so that means sp3 hybridized, right? 4 different things, right? So they have these asymmetric centers, and normally with all molecules, that means they're going to be chiral. But these molecules are actually achiral. It's because they have an internal mirror plane. So the way I always remember this is that us people, are meso compounds ourselves. Right? And the reason I say that, if I drew a little stick figure, right? Right? We have right hand or hands that are different. They're mirror images of each other, right? And we also have feet that are mirror images of each other. But so we have asymmetric centers, but we also have an internal mirror plane. Like you can cut us down the middle, and more or less, it's the same on either side. So an example of this for a molecule would be something like this, where, right, you have asymmetric centers. You have atoms that are sp3 hybridized bond to 4 different things. Right, you could do rankings, you could do RNS. Right, you have at least one, and the molecule has an internal mirror plane. So this is a molecule, we call it meso because it has asymmetric centers, but it's actually achiral because it has this internal mirror plane. So a good question just come up, right? What if I added a chlorine down here? Again, you still have that internal mirror plane actually. Whether this is wedged or hatched, you still have that internal mirror plane for sure. So what if one was hatched and one was wedged? Now there's not a mirror plane, right? Because if you slice this down the middle, one's pointed down and one's pointed up. So it's actually not a mirror plane or a mirror image, right? That look, 2 things exactly the same looking at each other. So yeah, so they have to be on the same side. They could both be hatched, they could both be wedged, but if one's one or the other, then they're no longer a mirror image of each other. Or they have an internal mirror plane.